All right, we're on our last page. We are just going to use our limit definition of derivative again to find f prime of x, and then we are going to find the tangent lines. So to start out with number 3, we have f of x equals square root of x plus 2. So we're going to use the formula, limit as h approaches 0, square roots. Instead of x, we're just going to replace it with x plus h, and then plus 2. And then minus square root of x plus 2 all over h. So hopefully that form seems a little familiar. Do you remember what we need to do in order to find a limit like this? So hopefully you remember this is where we rationalize. So we're going to multiply by the conjugate, square root of x plus h plus 2 plus square root of x plus 2 all over square root of x plus h plus 2 plus square root of x plus 2. So we have the limit as h approaches 0. FOIL that top part out. So you're going to have x plus h plus 2, that's your first part, minus the quantity x plus 2. So be careful there. You multiply negative square root of x plus 2 times positive square root of x plus 2. So you're going to have to distribute that negative. And then leave the denominator alone. Do not expand it. We're going to try to cancel out that h. That's our goal. So you need to make sure that you leave it in factored form. Okay, up top, you can distribute that negative if you want, or you might already be able to tell. The x and the minus x will cancel out. The 2 and the minus 2 will cancel out. So what we have left is the limit as h approaches 0 of just h on top over h times square root of x plus h plus 2 plus square root of x plus 2. Now we see that the h's cancel out. So we have the limit as h approaches 0, 1 over square root of x plus h plus 2 plus square root of x plus 2. And then to evaluate that, we just plug in 0 for h. So we have 1 over square root of x plus 0 plus 2, or just x plus 2, plus square root of x plus 2. And so that is 1 over 2 square root of x plus 2. We have 2 of those in the denominator. And that is our equation for f prime of x. So 1 over 2 square root of x plus 2. That's f prime. Remember, that represents the slope of the tangent line. So what we're going to do next, we're going to jump down to this part at the bottom. We're going to find the equation of the tangent line to the graph of f of x is square root of x plus 2 at x equals 7. So we're still going to use that form, y minus y1 equals m times x minus x1. And so in order to use that form, which is called point-slope form, you need a point and you need the slope. So to find the point, you need to find f of 7. It gives us the x value, so we need to plug that in to our original f of x equation and calculate it. So we have square root of 7 plus 2, so square root of 9, which is 3. And that gives us the point then 7, 3. That's our point. For the slope, you plug the 7 into your derivative. That's the equation we just found up there. So 1 over 2 square root of 7 plus 2. So that's 1 over 2 times square root of 9, which is 3. So that's 1/6. That's our slope. The last step, we just need to write the equation. So y minus y1, which is 3 from our point, equals our slope, 1/6 times x minus 7. That's it. You don't need to simplify. You especially don't want to simplify on a problem like this. If you distribute that 1/6, you're going to have 7/6 right here, and you're going to have fractions, and then you add a 3. And, you know, everybody's just not that great at fractions, so we want to keep this as simple as possible. Just leave it alone. Don't expand it. Don't get those points taken off. All right, let's move on to our last example. We're going to move back up to the top. And let's find the derivative of 3 over x plus 2. So limit as h approaches 0, 3 over x plus h plus 2 minus 3 over x plus 2 all over h. So remember, we just take the x, replace it with x plus h. So this is one of those complex fractions. And remember, you can either find a common denominator up top and combine those fractions, but the shortcut when you're simplifying these is just multiply by your most complex denominator. So in this case, we're just going to multiply by both of the denominators. And we have to do that to both the numerator and the denominator of the main fraction. When we do that, I'm not going to write out every single detail here, but when you multiply 3 over x plus h plus 2 times these two denominators, the x plus h plus 2's will cancel out. So you'll only have 3 times x plus 2 left for that fraction. For the second part, the x plus 2's will cancel out. So we have minus 3 times x plus h plus 2. That part is still there. And then we have still in the denominator h times x plus h plus 2 times x plus 2. Remember, do not expand the denominator. We want to leave it in factored form. So limit as h approaches 0, 3x plus 6 minus 3x minus 3h minus 6 all over h times x plus h plus 2 times x plus 2. So 3x cancels out, 6 cancels out. Again, notice the only thing that's left has an h in it. So limit as h approaches 0, minus 3h over h times x plus h plus 2 times x plus 2. So the h's cancel, and then we can plug in 0 for h. Someone's calling. And so we get negative 3 over x plus 2 squared. So that is our f prime of x. So that is our derivative equation. So the last thing we want to do is find the equation of the tangent line. Once again, you need the point and slope. The point means you plug in 1, f of 1. So just plug that into your original equation. 3 over 1 plus 2 is 3 over 3, so that's 1. So our point is just 1, 1. Our slope means you plug 1 into f prime, our derivative. So negative 3 over 1 plus 2 squared. I'm using this equation up here. So negative 3 over 9, which is negative 1/3. That is our slope. So our equation, y minus 1 equals negative 1/3 times x minus 1. And that is it. All right, so that is how you find derivatives and equations of tangent lines.